So let's say I'm given a problem here, a polynomial function, and so we're supposed to try to solve for it and find all the zeros, including complex and real numbers. So the first thing we want to do is we define our possibilities. So we divide our p. So our p is the end thing of our the last number of our polynomial function, and the q is the beginning of our polynomial function. So we'll divide p by q. So in this case, it's basically like saying 15 over 1. Also trying to find all the possibilities for it. So if we write our possibilities down, we will get positive or negative 1. You know what numbers that go into 15 by mean. So then we have positive and negative 3. That's my bet. And positive, negative 5. Positive and negative 15. And this is all over positive or negative 1. So now we have our possibilities. So we can use synthetic division to solve and find the zeros for it, but that would like take forever to find the true zeros given these possibilities. So this is where our graphing technology comes in. So if you have access to graphing technology, you'll graph this, and so if you graph this, you'll get a graph like this. And so it looks like our line intercepting the x-intercept. So to find a zero, it's always going to be at the x-intercept where the x line where it intercepts. So in this case, we have a 3 here. So 3 is one of our zeros. So now if we go back to the problem, we know that one of our zeros is 3. But we're not done here, because here's the problem. Because in a polynomial function, you can tell the number of zeros by looking at the degree. So degree is 3. We have 1 right now, so we have to find the rest. And just based on by looking on the graph, we can tell the rest of the numbers are imaginary because they don't exist. And so we can still solve this. So using this 0 right here, we can find the rest of the numbers. So we can use synthetic division to do this. So we put 3 right here, and so we put our polynomial function right over here. But we had to drop all the variables, so it'll be just 1, negative 7, 17, and negative 15. So then first thing we'll do this problem is drop the 1. You drop the first number, so it'll be 1 right here. And so we have 3 times 1, that's 3. And you're adding all these, so I'll just put a plus right here. So it'll be 6, 5, 4, that'll be negative 4. Negative 4, and then we do it 3 times negative 4, that's negative 12. And then 17 plus negative 12 is 5. And then if you do 3 times 5, that's 15. And so negative 15 plus 15 is 0. And so when you have a 0 right here, you can tell that you did it right, because the goal is supposed to get to a quadratic form, not polynomial. So we can write this as x minus 3, because we're writing this down as a factor form. And then we have x squared minus 4x plus 5. So now to find the rest of our zeros, we have to like use the quadratic formula with this quadratic function right here. So we can write this as negative 4. Just gonna write this out like this. So you have negative 4 squared minus 4 times a, which is our 11, because that's our, nope, sorry, 1, that's 1, my bad. I thought I would have misread that. So because our a is right here, so we times 1, and then times c, which is 5. So then if we write as this, I'll just put another arrow right here, we will get 4 positive negative square root of negative 4. And now this is where something interesting comes in. So now we have a negative. We can't, as you know, we cannot square root a negative number. So we either write it as an imaginary number. So if we were to write it as this, we will get 4 plus positive or negative 2i, because it represents the negative, and divided by 2. And finally, we will write it as this. So 4 divided by 2 is 2, positive or negative. 2 divided by 2 is 1, so we just 2 positive I. So we can write these as two answers because they're both positive and negative. So we have 2 plus I and 2 minus I. And those are our rest of our zeros. So the final answer right over here is x equals 3. And then we have 2 plus I and 2 minus I. And these are 3 zeros. And so like again, if you feel like you're missing something, like a zero sum, always check your polynomial degree.